If we got to finish checking a few homeworks tomorrow before the test, that's fine. Oh, like there was a leg or something there at the start. Okay, division. As you can see, solve these divisions. Hey, more dividing. Guess what? Even more dividing. So very singular focus for a lot of the chapter. Over here is some of the different stuff we saw at the end. So usually there's nothing. All right, so divide. I went through short division with the fifth grade yesterday. Man, they got up in a roar about it. So I'll kind of rotate between short division and long division on these. So long division, 5 doesn't go into 4, 5 goes into 49 9 times. 9 times 5 is 45, 49 minus 45 is 4, drop the 0, 5 on 40, 8 times. 8 times 5 is 40, drop the 1, 5 doesn't go into 1 at all. 5 goes into 13 twice, 13 minus 10 is 3, drop the 5, a 7, no remainder. 98,027. Short division. 2 goes into 2 one time. 1 times 2 is 2. 2 minus 2 is 0. I don't usually write zeros. I will this time. 2 goes into 4 twice. 2 times 2 is 4. 4 minus 4 is 0. 2 goes into 9 4 times. 4 times 2 is 8. 9 minus 8 is 2 goes into 16, 8 times. 8 times 2 is 16. 16 minus 16 is 0. 2 goes into 5 twice. 5 minus 4 is 1. 2 goes into 19, 9 times. 19 minus 18 is 1. 2 goes into 18, 9 times. 18 minus 18 is 0. No remainder. Solved using short division. So totally optional if you use short or long division. Hopefully you got the right answer though. I'll check 1 or 2 of them later on. I'll save that for a bigger problem. All right, 93. I see 90 just for trying to figure out what to put here. Remember, you want to try and use this compatible number estimating skill to try and ballpark where you need to be. You may be off by 1, right? Maybe off. But hopefully you're not starting with an 8. 93 times 8, say, oh boy, that was too big. What about 7, right? Those would be not good starting spots. So 3 seems like a good spot. 90 times 3 is 270. I got 301. 93 doesn't go into 3. It doesn't go into 30. I'm starting in the hundreds column. 93 goes into 301. 3 seems reasonable. A 9, 279, a 2, 22. Drop the 3. 2 seems like a reasonable number. We already know what 93 times 3 is. It's 279. That's obviously not going to work. 7, 3, 9. 93, that was 2. Let's try a 4. A 2, 362. No, 372. 372. Remainder 7. Short division really only works with single digit divisors. I would never ever try to do it with something like this. So if you're using short division, remember it's kind of limited in its scope. It can help you with single digit divisors really nicely. But long division, that's what you're going to need to do here. I'll randomly decide to check this one. So to check any answer, take your answer. That's this right here, the quotient. Multiply it times your divisor. Solve the multiplying. 12, 7, 9, 0, 6, 36, 18, 21, 29, 2, 13, 11, 6. 2. That doesn't seem right at all, does it? What did I do wrong here? Oh, 9 times. Oh, that was a 9. That's why. 30. So So I get 30,132. 324 times 93. But don't forget about your remainder. That gets added on. If I add 7 more, 30,139. 30,139. That's where I started the whole thing there. I can feel very confident that my answer's right. If these two numbers don't match up, then either you did a division error or a multiplying error. But there's an error somewhere in the works. So where the error could be, well, there's all sorts of spots. Could be a subtraction. I mean, who really knows? But there's an error somewhere. There's somewhere. All right, number 4, 759. Again, try and use a little common sense. You may have to build a little bar over here off to the side. That's fine. Subtract 3 with a remainder of 433. Is what it would be. 759 times 3. 2,277 plus 433, 2,710. All right, choose the best estimate. Again, I've written it in a way that it's more about place values than what's, getting the right numbers. No zeros, 1 0, 2 0, 3 zeros. How many zeros do we need? 6,000 divided by 20. Cut a 0 off both sides. 6 divided by 2 is a 3 with 2 zeros, 300. 300 times 20, 3 times 2 is 6. 1, 2, 3, 1, 2, 3. Yep, 300's the missing number, 300. Good with that? I assumed as much. More dividing. You should not need to set up a division bar here. 6 and 7 are powers of 10 division. Whenever we're dividing by powers of 10 greater than 1, each 0, or each power of 10, we just move the decimal the same number of corresponding spots to the left. So if I'm dividing by 10, that just means I moved my decimal 1 spot to the left. If I'm dividing by 100, that means I'm moving my decimal 2 spots to the left. A 1, a 2, right there, not that 7, but 0.00245. Moving the decimals, that's all you need to do in 6 and 7. If I'm dividing by 1,000, then I move the decimal 3 spots to the left. If it's a whole number, I'll make it 20. If it's a whole number, remember, all whole numbers have decimals. You can just put it in yourself, a 1, a 2, 3. 200s. It would be if I had 20 divided by 1,000. So if it's a whole number, you can make the decimal yourself. 1,000, 3 spots, 100, 2 spots, 10, 1 spot. Right? More dividing. A couple bigger ones, decimals thrown in, a money one. Number 9's money. So decimals in here. There can be a decimal in the dividend, no problem. Not so much on the divisor, though. So assume here none of these have remainders. I don't have to add zeros. That'll be more this type of stuff. The next page here where we got to add zeros and stuff. So expect all these here to terminate cleanly for you. You shouldn't have remainders or really anything with these problems. Same thing on your test tomorrow. I'll remind you, but 8, 9, 10, and 11 should not have remainders. If you get a remainder, guaranteed you did something wrong, right? Same thing tomorrow. So anyway, 42 doesn't go into 3, doesn't go into 34. 9 times 40 is 360. That's going to be too big right off the bat. So 8 seems reasonable. 336, a 3, a 1. I already got my decimal. 40 times 3 is 120. That would be 126. There's an 8, a 4, 42 into 84, 2 times. Terminates 8 and 32 hundredths. You can use short division here, or you can use long division. 4 doesn't go into 2. 4 into 24 6 times. 24 minus 24 is 0. 4 goes into 1, 0. 1 minus 0, 1. 4 into 12, 3 times. $6.03. This one here, now I have decimals in the divisor. Again, on your test, you'll see the same type of questions in the same spot with the same obstacles to resolve. So I'm not trying to trick you or anything here with any of this stuff. But decimals in the divisor, can't have that. First step, move it. Move that one spot to the right. If I move that one spot to the right, I move that. If you need to rewrite it, rewrite it. If you don't need to rewrite it, then don't. Whatever you need to do to get the right answer. On that quiz, though, some of you were not very effective at your decimal placement here. You could do the division and get the non-zero part right, but where the decimal went in that final answer was kind of all over the place. Some of you moved it too far to the right or too far to the left, or you all know what I mean, I think, from your prior quizzes this chapter. So whatever you got to do. If you're going to rewrite it, then rewrite it. This is essentially what you're solving here. If you can just slide it and represent it this way and get it right, then do it that way. Whatever's your thing. If you want a short division, 8 minus 7 is 1, 7 into 16 twice, 16 minus 14 is 2, 7 into 21, 3 times, 12 and 3/10. Short division. 12 and 3/10. If your decimal is somewhere else, why? What happened? Shouldn't be. 7 into 86. Think about it like this. 86 into 7, that's close enough to 91 divided by 7, right? Obviously, 91 divided by 7 is 13. Duh. If you don't have an answer around 13, what's wrong with you? 91 divided by 7, mental math. Everybody knows 91 divided by 7. See how fast I put it up there?
Yeah.
When I was thinking about my compatible numbers to do with this problem, I kind of struggled with the 7. So, well, anyway. We could probably agree 12 times 7 is somewhere around 84, which is close enough, right? How about that? So if that helps you or whatever, why do I mention it? I mean, just is there a way to quickly verify if this is in the right spot? 12 times 7 equals 84, which is generally close to 86. I'd feel like this is probably in the right spot. This decimal right now, 12 times 7. 12 times 7 is about 86. Right? Or 12 times 7/10 is about 8 6/10. Move the decimal 2 spots to the right. 75 into 77 and 2500. 75 into 77. A 2, drop the 2. 75 doesn't go into 22. Nope. 75 into 225, 3 times. No remainder. 1 3/100. 1 3/100. 1 3/100. 1 3/100. So not 103, not 0.000000000103, but 1.03. Right, decimal in the right spot. Good with that?
Yes.
Excellent. Comparing. Again, you don't need to show me any work here much, except you should be able to estimate on both sides. When I divide a number by a number that's smaller than itself, the number will always be greater than 1. Whenever I divide a number by a number that's smaller than itself, my answer will always be 1, or greater than. So this, I am dividing by a number greater than 1, or less than 1. This is also greater than 1 on this side, over there. If I'm dividing by a number, just theoretically here, if this was the problem, right? If I divide by a number that's bigger than my number, well, then my answer's always going to be less than 1. Always. Always, always, always. That's what I'm checking for here. I don't need you to build division bars for these two problems. If you really want to or need to, I'm not saying you can't do it. Get the answer right. Show me something. But I'm just seeing 27 divided by 7 greater than 1. I'm seeing 12 divided by 1 equals 12 on this side, right? 1 is clearly less than 12. So this is what I'm checking for here. Just looking at this. Greater than 1, greater answer. Greater than 1. If you divide by something bigger, then you'll get an answer less than 1, smaller than 1. You're comparing them against 1. Okay? Again, I don't think this was one of your strengths either on the quiz for some of you. This wasn't really where you shine the brightest, but it doesn't need to be that hard. It's just this. 4 divided by 2 is certainly going to give me an answer bigger than 1. 2 divided by 4 is going to be the same as this, which is certainly going to be an answer less than 1, right? And anything divided by itself, of course, equals 1. Right? Anything divided by itself. But if I have a number smaller than, it's going to give me something greater than 1. And if I have something that's bigger, well, then it's going to give me an answer less than 1. It's always going to be like that. Always, always, always. Okay? Good? Flipping the page. Even more dividing. So, these will be the, I guess you could say the harder ones here. You will need to add place value zeros and stuff like that here. Should not have remainders. No remainders. You should be adding zeros until it terminates. So first thing I got to do here, though, is I got to move the decimal 2 spots to the right. So 1, 2. So now my decimal's over here. Basically, it's 32 into 40. 32 goes into 40 one time. Here's an 8, and again, here's my decimal. 32 goes into 80 2 times. I'm after the decimal now, by the way. Subtract 64, 16, add another 0, a 5. Now it terminates 1 and 25 hundredths. You can check it. I'll spare you. But if I did 1 and 25 hundredths times 32 hundredths, that's 4 decimal spots. By the time you got doing, you'd have 0.4000. 1, 2, 3, 4. There's where you would be, right back to where you started this thing. 6 into 3. It's not 3 into 6. So 6 doesn't go into 3 at all, but 6 goes into 30 5 times. Done. 5 tenths. Big thing there is hopefully you didn't rate 2 for an answer, because then that's a different problem, right? Round to the nearest hundredth or nearest cent, just like I told you it would be. This is the one. So that means how many decimal spots does this need to work? Right. So I can add them right now if I want. Maybe it terminates. If it terminates, not necessary, but there's my 3 decimal spots. Once I get to this spot, I'm done. Once I put a number above that 0 and that 0. So this one, I got to move it. And if I move it, guess what that means? Now I need another 0. Right? Now I need another 0. So 7 goes into 45 6 times. 42 is a 3 after the decimal now. 7 into 30, 4 times. 28, 2. Hasn't terminated, keep going. 7 into 20, 2. 14. There's my 2 spots, but I don't know if I'm rounding this up to 6 and 43 hundredths or staying at 6 and 42 hundredths. 60. That's like 8 times. That means I'm rounding up. That means if I'm going to the nearest hundredth, 6 and 43 hundredths is what I need. And again, I don't care. 8 times 7 is 56. I don't need to keep there's no point anymore. I've reached where I need to stop. All right, this one here, money, 3 goes into 5 once. Here's my decimal, drop the 1, 3. 3 into 21, 7 times. A 0, drop the 9, 3 into 9, 3 times. It terminates. I don't need a third decimal. If I had it, it would be a 0. A 0 to 4 means stay where I'm at, or round down. But this one terminates before I hit that point, so I don't need to keep going. $1.73 is the answer. Good with that. Find the variable. So, I assure you in the past here, I've worked these out. I'm not, for time purposes here, I don't think you're very excited to watch me grind out these division problems. But if you work it all out, you should get 500 too. Okay? Nothing, 5 minus 145, and away you go with it. This one here, again, build a division bar, obviously. Probably need another sheet of paper. If this isn't enough space, I get it. 3,054. Once again, because this is algebra work here, you will not have a remainder. This is an equation. You are solving. So there'll be no remainders on 18 and 19, 20, or 21. No remainders. I'll remind you of this tomorrow. But that should be a help, because when you're doing this here, if you get something that has a remainder in it, you can instantly be like, something's wrong, without even having to check it. You already know something's wrong. So that'll help. Keeping that info, and I'll remind you of all this tomorrow. Okay? Number 20, this is powers of 10 type stuff again here in a different form. This is where I started. I divided by something that moved my decimal one spot to the left. What do I divide by that makes my decimal move one spot to the left? I divided by 10. Because the decimal was here and it moved one spot to the left, must have divided by 10 to move that decimal one spot to the left. Here I am now, I divided by 1,000, which meant the decimal moved 3 spots to the left. So where did I start though? 1, 2, 3. I started at 50. Because again, when I move it 3 spots to the left, this is where I end up. A 1, a 2, a 3. That's where I ended up. Where did I start though? I started at 50. I moved it 3 spots to the left. I ended at 500. So again, this is tricky. This was tricky for you guys. Again, just pause. It shouldn't be hard to just plug this in and go 3 spots to the left. 1, 2, 3. Okay. Yes, that's right. Yes, that's where I started. It's not that hard to check. 2 more powers of 10. Powers of 10, 6 and 7. Powers of 10, but in a different way this time when we saw it later on this chapter again. Just sliding decimals. You don't need to grind out hard work with this. That's not the point, right? So just powers of 10. This is what you're looking for. This one, you're missing the power of 10. This one, you're just doing it the other direction, backward. I know where I ended. Where did I start the problem, right? Okay. Answer's 50, by the way. Catch that. Okay, good with that. Okay, 21, write in scientific notation. Scientific notation needs 2 things. A single digit number between 1 and 9. It can have decimals. And then multiplied by 10 to some sort of power. So multiplied by 10 to something. The single digit number is you just place your decimal wherever it would be. So this first digit here is somewhere between 1 and 9. Has to be between 1 and 9. Greater than or equal to 1, less than 10. Okay. So 1 and 5/10 meets it. Now the question is, how many spots did the decimal move to get there? It moved 1, 2. I divided by 100. Essentially, that's the same as multiplying by 1 over 100. That is -2. Yes, Michaela?
Can I get Brandon from
Yes, you can. You bet.
You want me to sign up?
No, you don't have to say that. So this would be it. 2 things I need. Single digit number between 1 and 9, essentially, multiplied by 10 to a power. Positive exponents represent large values. This would be 150, positive 2. Negative exponents represent tiny values. The decimal moves to the left. The number gets smaller, right? So you'll only see negative exponents on your test, but just as a refresher, why, how, what does it all mean? There you go. So here, where do I start at 9? If you write 9.0, that's fine. Times 10. How many spots did it move? Count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Moved it 9 spots to the left. Therefore, -9. Okay. Write the word phrase as a numerical or algebraic expression. Use n if it's algebraic. 32 divided by 8, 32 divided by 8. You do not need to solve. A number multiplied by 29. A number multiplied by 29. I would probably accept it this way for this one just because this is the standard form. Again, lots of ways you can write multiplying. Evaluate. Again, this was some of you, I don't know what happened. The homework, I don't know. Not your best effort on this one, though. So, A times B divided by 2. So, 55 times 4/10, a 20, a 220. That would be 22. And then 22 divided by 2 equals 11. There's my final answer. A, 55 divided by 5 equals 11 times B, 4/10, 44, move the decimal 1 spot, 4 4/10. 4 4/10. 27. Candy store sells 1,000 gumballs for $990. How much would a dozen gumballs cost? So first thing I need to figure out is how much one gumball costs. Before I can figure out a dozen, I need to know how much one gumball costs. So take however much they cost, divide it up. There's 1,000 of them. Each gumball, all you do is slide the decimal, a 1, a 2, a 3. Each one costs 99 cents. One gumball, 99 cents. Once I know that, one's 99 cents, multiply it by 12, because there's 12 in a dozen. 99 cents times 12, they would cost you $11.88. 12 gumballs. So figure out how much one costs by using your division, 99 cents each. Then multiply by 12 to figure out how much a dozen would cost you. Right? 28, bookstore. Displays a variety of models. Each model of a school is built entirely from miniature bricks. Oh. Each brick has a mass of 115 grams. Oh. A model school has a mass of 143,175 grams. Oh. How many bricks are used this model? So, division. Total amount divided by the mass of a brick would tell me how many bricks I need. And again, I'll spare you watching me solve a division problem. It would be 1,245 bricks are used in this model. 1,245 bricks. We're about to start checking homework. No, we've got 20 minutes left. You can take a little break. Okay, I'll come check on you. Okay. Good with that? Great.